Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. Okay, to all of you. So today we like discuss about the tutorial ones. Okay, all right. So if you check on your tutorial one, okay, we have a 12 question. All right. So we discuss question. Let's check question number one. Actually, question number one is the theoretical. So the answer you can get from the notes. Okay. So question number one is explain the difference between the systematics and random errors. Okay. What is the typical sources of these two type of errors? Okay. So this one is the theoretical. So you can get from the answer you can get from the notes. Okay. So we proceed for question number two. Okay, so question number two will be a circuit measurement of the resistance, okay, of 550 ohms is certified by connecting together two resistors of nominal value 220 ohms and 330 all right ohms in series. Okay, if each resistor have the tolerance of plus minus 2%, calculate the error in the circuit in the both absolute and percentage error. Alright, so for example, okay, the question is a RT, the R total. Okay, R total we have the 200 ohms. Alright, so we have the R1 we have 200, okay, 200 ohms, and then R2 is 330 ohms. Okay, because of this one is a RT is a series. Okay, resistor in series. Okay, we have to add lah. Alright, so this R1, this R2. Okay, for calculate the RT. Okay, for resistor connect in series. Okay, so we just add lah. For example, 220 plus 330. Okay, so that's why RT we get 550 ohms. Okay, and then the both will be tolerance is plus minus 2%. Okay, plus minus 2%. For R1 and R2 is 2%. Okay, the first step we have to calculate the tolerance lah. Okay, 2%. Okay, calculate with 220. Okay, get around, okay, you can use your calculator, so around 4.4 lah. Okay, this one 4.4 ohms. Okay, and then similar like this one 2/100 multiplied by 330 ohms. Okay, so we get 6.6 ohm. Okay, because this is a tolerance, is a connect in series, so we can plus, okay, R1 plus R2, so that's why we can get the 11 ohms. Okay, so this is 11 ohms. Okay, from this 11 ohms we can calculate the absolute error and percentage of error lah. Okay, for example, this 11 with 150 ohms. This means we can, okay, 11 multiplied by 100 lah, 100 in percentage, percentage. So we can get the plus minus 2% lah. Okay, this is a percentage of error lah. Okay, percentage of error, and this one is the absolute error lah. Okay, absolute error. Okay, this is for question number one. Right, so we proceed for question number two. Okay, sorry, this is question number two. Proceed for question number three. Right, question number three, the current through the resistor is 1.5 amps. Okay, but the measurement yield a value of 1.46 amp. Compute the first, you have to calculate the absolute error. Second, percentage error. Third is the relative accuracy, and fourth is the percentage of accuracy for the result. All right. So for this is for question number 3. Okay. So clear all drawing. Right. So we proceed for number 2. number 3, sorry, this is number 3, yeah, tutorial number 3, tutorial 1, number 3. Okay, so the expected, okay, we put as the yn is the expected result is 1.5 m, and then measured, okay, we can set as the n is a measure is 1.46 m. All right, and then first we have to calculate the absolute error lah. Absolute error, okay, expected minus with measured lah. That is the absolute error. Okay, so the answer is 0.04 m. That is absolute error. Okay, so question number 2 will be percentage of error lah. Percentage of error. So this is absolute error. Okay, divide by expected. Okay, multiply by 100 percentage. Okay, so the answer will be 2.67. Okay, percentage. Alright, so that is for percentage of error. Okay, now 4 is the relative accuracy. So the formula for calculate the relative accuracy 1 over yn minus expected minus with xn divided by yn. Okay, so 1 over, okay, so this is 0.027. Okay, so that's why the answer is 0.9, 0.9, okay, 0.9 lah, 0.97. Okay, and then number 4 is the percentage accuracy. So percentage accuracy 0.97 multiplied by 100 because of in percentage, so it's the 97. Okay, so that is for number 4 is the percentage of accuracy. Right. Okay, next we go for question number 4. Okay, question number 4. Okay, we have a 6 student. Okay, 6 student using the one oscilloscope with following measured the output voltage of the amplifier. Okay, so we have 6 measurement. The first measurement is 20.22. Okay, we have 6 measurement. Okay, measurement 1 20.2 volts. Okay, number 2 we have 19.9 volts. Okay, number 3 we have 20.05 volts. Okay, number 4 we have same, okay, 5 volts. Okay, number 5 we have 19.85 volts, and last is we have 20 lah. Okay, we have 20 volts. Okay, we have four measurement. Okay, sorry, we have 6 measurement. So the question is we have to calculate the precision of the fourth measurement. Okay, we have to calculate the fourth measurement here, and then which the both of the above measurement is the most precise. Okay, so first, this one we don't give any expected we don't give any expected result. For example, this one we don't know the expected result, so the method we can use is the average lah. We find the average. Okay, so we calculate all the value here and divide by 6 times. For example, okay, this one data number 1, okay, plus 2 plus 3 until so total we can get, okay, 120.05. okay, and then divide by 6 because we have the 6 measurement. Okay, 6, the answer will be 20.008. Okay, this is we call as average x. Okay, we call the x bar lah, for example. So from this one we can calculate the error lah. Okay, for next you can calculate the error. That means the x bar, the expected result. Okay, the expected result minus with data number 1. Okay, and then for this for data error for number data number 1. Okay, and then next expected is 20.008 minus with 19.9, for example, and so on. Okay, so for example, the error first question is 0.008. okay, 192. Okay, and then next negative. Okay, 0.108. Okay, number 3, 0.042, same. Okay, for number 4. Okay, and then negative 0.158, and then last one is negative 0.008. Okay, and then from this one we can calculate the precision. Okay, the precision. Okay, so the formula for precision is 1 over expected minus with measured, ni called y lah, y1 divided by uh, okay, so this is measured and then the expected. Okay, this one divided by expected. Okay, so and then you can get the precision lah. Right, so for example, the precision for number 1 is 0.9904. Okay, this one 0.9946, 0.9979. Okay, will be same lah, because our value will be same, right? So 0.9921, and last one 0.996, sorry, 96. So for example, the precision number 4 is this one lah. Okay, is that in percentage we can get is 99.79% lah in percentage, right? Okay, or this value lah. Alright, so the most precise is the almost to 1 lah. Almost to 1 is the number 6 lah. Okay, this is more precise lah. Okay, for example, the 6 measure is more precise because of almost to 1. Okay, almost to 1. That is for question number 4. Right, so we go for the next question. Okay, question number 5. Okay, question number 5. The question is two current from different source flow in the opposite direction through the resistor R1. Okay, I1 is the measured as the 79 milliamps on the 100 milliamps analog instrument with an accuracy of plus minus 3% of the full scale. Okay, that's for I1. So I2 is the determined as the 31 milliamps is measured on the digital instrument with plus minus 100 micro accuracy. So calculate the maximum and minimum level of the current in R1. Okay, so this one first. Okay. Okay, so question number 5. So we have the R1 here. Okay, so this is I1. Okay, and opposite, I2 is the opposite direction of the I2. Okay, so for I1, okay, given we have the 79 milliampere. Okay, but measure from the hundreds, the scale, 100 milliampere plus minus with 3%, plus minus tolerance is 3%. Okay, and then I2 equals to 31 milliampere. Okay, plus minus 100 microamp lah. Okay, so first we have to calculate the I max lah, I1 max, IT max. Okay, so the 79, okay, milliampere. So 79 milliampere come from this one lah. All right, come from this one is because Okay, equivalence to 79 milliampere plus minus 3 m. Okay, so plus 3 m here. Okay, minus with 51 milliampere minus 100 microampere. Okay, so it 2 milliampere minus 30.9 milliampere. Then the answer will be 51.1 milliampere. Okay, that is for current max. Okay, so the current T minimums is the 79 milliamps. Okay, minus with 3 amps. Okay, minus with 31 milliamp plus 100 microamp. Okay, so 79, sorry, 76 milliampere minus 51.1 milliampere. So the answer will be 44.9 milliampere. All right, so that's the range lah. Okay, so this is max. Okay, the max current, and this is minimum lah. Okay. All right, so this is for the question number 5. All right, so then we go for the question number 6. Okay, you can see 6. We have the resistor box has the following components and tolerance. Okay, so you can see on the tutorial 1, number 6. Okay, we have 10 resistor, each of 100k kilo ohms. Okay, plus minus is 0.05, and then 10 resistors, each of the 10 kilo ohms plus minus 0.05. Okay, we have 10 resistor, each of the 1 kilo. Okay, plus minus 0.05. We have 10 resistors, each of the 100 ohms plus minus 0.1. Okay, and then last one is we have 10 resistor, each of the 10 ohms plus minus 0.5%. Okay, and then we have to determine the both in ohm and percentage, the limit of uncertainty in the setting of 453.72 kilo ohms. Okay, that is for the question number 6. Okay, we go for the question number 6. All right, that is question number 6. So we have to find the R, given R equals to 453.72 kilo ohms. Okay, so from this one we know. Okay, so 4 multiplied by 100k to get this one. Okay, 5 multiplied by 10k plus 3 multiplied by 1k plus 7 multiplied by 100. Okay, and then last is the 2 multiplied by 10. So that's why we can get this answer lah. Okay, 453.72 kilo ohms. Okay, so this one. So from this one we can get lah. Alright, so this one the limiting error, the tolerance for every resistor here given. So this one will be 0.05, this one 0.05, this one 0.05, and this one is 0.1, and then this one is the 0.0, sorry, 0.5. This one 0.5. Okay, so one last one 0.5 lah. Okay, and then we can calculate lah 0. Okay, for example 0.05 plus 100 multiplied by 100k equals to 50 ohms. Okay, 0.05 multiplied by 10k, this one k percentage multiplied by 10k equals to 5 ohms, and then 0.05 divided by 100, okay, multiplied by 1k equals to 0.5 ohms. Ohms, okay, and then 0.1, 100 by 100, we can get 0.1. Okay, the last one 0.5, 100 multiplied by 10. So the answer will be 0.05. Okay, and then from this one we can, okay, from this one, okay, from this value we can substitute lah. Okay, for example, okay, 4 multiplied by 50, okay, plus 5 multiplied by 5, okay, plus 3 multiplied by 0.5, okay, 7 multiplied by 0.1, okay, plus 2 multiplied by 0.05. So that's why the answer will be plus minus 227.3 ohms. Okay, so that is the answer lah, the tolerance. And then you can calculate the percentage of tolerance for this. Okay, so 227.3, okay, divided by total is 503.72 kilo multiplied by 100 the percentage, so you can get the 0.05. Okay, so this is the percentage, this is the absolute error. All right. Okay, so that's for question number 6. Right, so next we go for the, okay, we go for the question number 7. Okay, on the 7 we give the tables. Okay, we have the 8 different students tune the circuit for resonance and the following value, okay, value for the resonance frequency of the circuit were recorded. Okay, compute the arithmetic mean, the average deviations, standard deviations, and probable error and of one reading and the probable error of means. Okay, all right, so we have 8 measurement, 8 measurement. Okay, we go for question number 7. Okay, question number 7, we have 8 reading. Okay, number 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 reading. Sorry. Okay, this is on the frequency 2, 5, 4, 8, 5, 4, 3, 5, 3, 5, 5, 4, 6, 5, 3, 1, 5, 4, 3, 5, 3, 6. So 3, 6. Okay, so this is a 8 measurement for the resonant frequency. All right, so first you have to calculate the average. So the average, so you have to add all the frequency here and then divide by 8. Divide by 8. Okay, so for example the total here will be 4,314. Okay, so the arithmetic mean you can get this one. Okay, divide by 8. So there is the 539.25. So the arithmetic means the means for this data. Then second, we have to calculate the average of deviation. Average deviation. Okay, average deviation. So can another, so can calculate the okay, this one number. Okay, the deviation is there. Okay, this one. All right, so deviation number 1, we can get 7.25. This one 7.7, 3.75, 4.25, 6.75, 8.25, 3.75. Last one 3.25. Okay, So this is the deviation, and then we can get the question number 2 is the average, average of deviation. So we have to add all this one, you get the 46, okay, and then divide by, okay, we can call it as the D. Okay, so this deviation is 46 divided by 8 lah. Okay, we have 8 measurements, so the answer will be 5.75. Okay, and then we can calculate the standard deviation. Standard deviation. Alright, so maybe we can get another column here. So for t power of 2, okay, so this one can use this formula lah. Okay, okay, this is answer number 1. Okay, you can use your calculator to get the power of 2. D power of 2, 6 to 5, 7, 6.5, 6 to 5, 14.0, 6 to 5, 18.0625, and so on. Okay, so on the total, okay, the average for this one, you get 9.5. Okay, then you can get the standard deviation. The formula will be T1 over n minus 1. Okay, multiply by summation of d power of 2 lah. D power of 2. Okay, so okay, 1, 8 minus 1 divided by 9.9, 2.995. Okay, so the answer will be 6.54. Okay, that is the answer. Then number D is the probable error. Okay, the formula of probable error is the number D is this formula, the formula is 0.6. You can refer to the notes, this formula, 45 multiplied by standard deviation. So this is standard deviation, plus minus 0.746 multiplied by 6.5, so plus minus 4.412. Okay, 412. Right, so that is the probable error lah. Okay, right, so next we can go for question number, okay, number 8, okay, and number 9, and I think the rest you can try lah. You can try by yourself. Okay, right, maybe I can explain for the question number 9. Okay, number 9, and then the rest you can do you can do it yourself. Right, so for example, number 9, just as for explain for the, we have the number 9, 0 to 150 volt. Okay, meter has the guaranteed accuracy of 1% full scale reading if the voltage measured by this instrument is 83 volts. Calculate the limiting error. So this one you have to calculate the limiting error. All right, so okay, I explain for the question number 9 lah. Okay, question number 9. Okay, so 1%, okay, of the tolerance. Okay, right, so the range from 0 to 150. Okay, so as we know, 1 per 100 is the 1 percentage multiplied by the full scale is the 150 lah. So the answer will be 1.5 volts. Okay, that is the plus minus tolerance. Okay, but the value by instrument is the 83 volt. So from this one, 1.5 divided by 83 multiplied by 100. So you can get the 1.81%. Okay, so this is we call the limiting error. Okay, limiting error for 83 measurement, right? Okay, so That's all for tutorial number 1. All right, so the rest you can try. Okay, you can try yourself. Okay, for example, question number 8, 10, 11, and 12. Okay, so I just discussed until 9, and the rest you can do it yourself lah. Okay, so thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh.